Dear students, in this video I am going to explain the gas laws and the derivation of ideal gas equation. Boyles Law. At constant temperature, the pressure of given mass of gas is inversely proportional to its volume. This is known as Boyles Law. P is directly proportional to 1 by V at constant temperature. If you remove directly proportional, you have to use equal to and proportional constant K. So P is equal to K into 1 by V. Send V to left side. Then PV is equal to K or constant. PV is equal to constant is the mathematical form of Boyles Law, or P1V1 is equal to P2V2. PV graph at constant temperature is called isotherm. On the left side of the screen, on x-axis volume and y-axis pressure is taken. Different temperatures 200K and 400K, 600K, the curved lines are called isotherms. P1 by V graph is a straight line passing through the origin, where T1, T2, T3 are the temperatures. T3 is greater than T2 and is greater than T1. Boyles Law. At constant pressure, the volume of given mass of gas is directly proportional to its absolute temperature. This is known as Boyles Law. What is meant by directly proportional? If temperature increase, the volume of the gas is also increase. So V is directly proportional to T at constant pressure. So V is equal to K into T, where K is equal to proportional constant. V by T is equal to constant. It is the mathematical form of Boyles Law, or V1 by T1 is equal to V2 by T2. There is a second definition of Boyles Law. At constant pressure, each degree rise in temperature, volume of gas increased by 1 by 273.15 of the original volume of the gas at 0 degrees C. So Vt is equal to V0 into 1 plus T by 273.15, where Vt is equal to volume of the gas at T degrees C, V0 is equal to volume of the gas at 0 degrees C. Each line volume temperature graph is called Isobar. Each line intercepts the temperature axis at minus 273.15 degrees C. All gases obey Boyles Law at very low pressure and high temperature. You can observe the graph. Isobars are intersect at one point, that is minus 273.15. At this temperature the volume is 0, but it is not possible for any substance. Boyles Law. At constant volume, the pressure of given mass of gas is directly proportional with the temperature. P is directly proportional to T, therefore P by T is equal to constant. So you can observe that the graph PT graph is a straight line passing through the origin. Avogadro's law. Equal volumes of all gases under the same conditions of temperature and pressure contain equal number of molecules. Mathematically, V is directly proportional to N and V is equal to Kn, or V by N is equal to K is also the mathematical form of Avogadro's law. Now we are going to understand ideal gas equation. First, what is ideal gas? A gas that follows Boyles Law, Charles Law and Avogadro's Law is called ideal gas. According to Boyles Law, V is directly proportional to 1 by P at constant temperature. According to Charles' Law, V is directly proportional to capital T at constant pressure. According to Avogadro's Law, V is directly proportional to N at constant temperature and pressure. From the above equations, we get V is directly proportional to Nt by P. Therefore, V is equal to R into Nt by P, where R is proportional constant. Later, it was named as universal gas constant. So, if you send P to this side, we get PV is equal to nRT. This is the ideal gas equation, and this is also called equation of state. Very important equation. Where P is equal to pressure of the gas, V is equal to volume of the gas, and N is equal to number of moles, R equal to universal gas constant, and T is absolute temperature. The temperature measured in Kelvin measure is called Kelvin scale, is called absolute temperature. Very important one is units of universal gas constant, that is R. From the previous equation, you know that R equal to PV by T. So R values in different units are 8.314 joule Kelvin inverse mole inverse. In joules it is 8.314, very important value. In ergs, 8.314 into 10 power 7 ergs Kelvin inverse mole inverse. In calories, R value is 2 calories Kelvin inverse mole inverse. In liter atmospheres, R value is 0.0821 liter atmosphere Kelvin inverse mole inverse. Very important. Hence, R depends on units of volume and pressure. Combined gas law. So, if you combine all the gas laws, you get P1 V1 by T1 is equal to P2 V2 by T2. This is very important formula to solve the problems. Thank you for watching. Like, share and subscribe. Thank you.